The shift began at 1:06 in the morning. Nothing in the control room suggested a problem. Reactor number 4 at the Chernobyl Nuclear Power Plant had been running for 3 years without a critical incident. The control room registered 3,200 megawatts of thermal output. Coolant flow moved at designed pressure. The gauges held their positions. The operators on the night shift had run this sequence before. The test was scheduled. It had been delayed 14 hours because the Kiev grid needed power. When authorization finally came through, the crew was tired. A fresh crew would have taken over by morning. Instead, the same operators who had been managing output all evening stayed at their stations and continued. The test required reducing reactor power to 700 megawatts thermal, a controlled reduction, standard procedure. The power dropped too fast, faster than the procedure expected. At 200 megawatts, the reactor became chemically poisoned by its own byproduct. Xenon 135, a neutron absorber produced during fission, had accumulated at levels the reduction had not accounted for. The reactor was suffocating itself. Output fell towards zero. The readings did not match the expectation.
The numbers were still moving.
The senior engineer on shift made a decision. To recover power, he withdrew control rods, the physical mechanisms inserted into the reactor core to slow fission. Standard response. The procedure for xenon poisoning required rod withdrawal to restart the chain reaction. He pulled more than 100 of them, more than the safety margin allowed. The reactor stabilized at around 200 megawatts. It looked stable again, far below the test requirement. The engineer held the rods out anyway and continued. The test began at 1:23 a.m. The conditions were no longer within design parameters. 4 main coolant pumps activated simultaneously as part of the test sequence. The additional pumps increased water flow through the core. The water, moving faster than the system was designed to handle, began converting from liquid to steam before it should have. Steam does not absorb neutrons the way water does. The reaction was no longer being slowed. The temperature rose. The pressure inside the fuel channels increased.
The system stayed active.
At 1:23 and 40 seconds, the shift foreman ordered an emergency shutdown. An operator pressed the AZ5 button. This was the moment designed to stop everything. All control rods were supposed to drop back into the core simultaneously. At full insertion, the rods would terminate the reaction in seconds. The rods began moving downward. They did not move as expected. They were made with graphite tips. Graphite, a neutron moderator, was used at the base of each rod to displace water when the rod entered. The design assumed a specific insertion speed and a specific reactor geometry. Under normal conditions, the rods worked correctly. These were not normal conditions. The reactor core had deformed under thermal stress. The channels that guided the rods were no longer perfectly aligned. The rods slowed. Some stopped. For 3 seconds, as the graphite tips entered the lower portion of the core before the neutron-absorbing sections could follow, the reaction accelerated instead of stopping. Power output spiked beyond measurable limits. The instruments in the control room could not register how fast it climbed. The system could no longer describe what was happening. The sensors had a ceiling. The actual output exceeded it.
They pressed the button.
At 1:23 and 47 seconds, the thermal power reached a level estimated later at somewhere between 30,000 and 33,000 megawatts. 10 times the reactor's maximum rated output, achieved in less than 3 seconds. The fuel pellets inside the pressure tubes began to fragment. Superheated fragments contacted the coolant water directly. There was no time for correction. The water flashed to steam instantaneously across hundreds of pressure channels at once. The steam pressure ruptured the reactor vessel. The 1,000-ton biological shield, a massive concrete and steel plate seated on top of the reactor, was lifted from its position and thrown upward. It came back down at an angle, exposing the open reactor core to the atmosphere. A second explosion followed within 2 to 3 seconds. Its exact cause was debated by engineers for decades. The result was the same. Material from inside the core was ejected through the roof of the reactor building and landed across the surrounding grounds. Some pieces landed on the roof of the adjacent turbine hall. Some landed in the open air. The graphite moderator blocks inside the core, each weighing several hundred kilograms, began burning on contact with oxygen. Graphite burns at temperatures that water cannot extinguish. The firefighters dispatched from Pripyat Station 2 arrived within minutes. They used water. They had not been told what they were approaching. No warning reached them. The dosimeters carried by the first responders read at the top. They reached their measurable limit, then stopped increasing and stayed there. Some of the instruments had a ceiling of 3-6 Röntgens per hour. Readings above that registered only as maximum. The actual radiation levels in some locations on the grounds exceeded 15,000 Röntgens per hour.
The instruments showed what they could show.
The fire on the roof of the turbine hall was contained by 6:35 a.m. The open reactor core continued releasing material. In the town of Pripyat, 5 kilometers from the plant, 49,000 residents woke to a regular morning. Buses ran, the market opened, children walked to school. An evacuation announcement was not made until 2 p.m. the following day, 36 hours after the explosion. Residents were told the move was temporary. They were not told why. They were told to pack for 3 days. Most left everything behind. The buses moved in convoys. The road out of Pripyat passed within view of the plant. The reactor building was still visible. Smoke and heat continued rising from the open core. Some residents on the buses looked out the windows as they passed. The convoy kept moving. The reactor core burned for 10 days. Helicopters dropped 5,000 tons of sand, boron, clay, and lead into the open structure to suppress the fire and reduce radiation release. The core temperature remained high enough that some of the material burned off. Workers on the ground were given maximum radiation exposure limits and rotated out when they reached them. The limits were revised upward during the response to allow more working hours per person. Engineers became concerned that the burning core might melt through the concrete foundation beneath the reactor and contact the groundwater table below. 3 volunteers, plant workers, entered the flooded basement beneath the reactor to open the drainage valves manually. The space was heavily contaminated. The water level was above the floor. They located the valves and opened them. The drainage took several days. Inside the reactor building, the core had collapsed into the basement level. The material, a mixture of melted fuel, graphite, sand, concrete, and structural steel, had combined under extreme heat into a dense, solid substance. It moved through the lower levels of the building in slow flows, following gravity, filling spaces and hardening as it cooled. Slowly, without resistance. One formation, later discovered in the basement, extended approximately 6 meters in length. It was dark brown. Its surface was rough. Its density was enough that standing near it for 300 seconds in the years immediately following the accident would deliver a lethal radiation dose. It had reached its final position. It sat in the basement of Reactor Number 4, motionless. The building above it was sealed with a concrete sarcophagus constructed in 206 days by over 200,000 workers rotating through short shifts. The structure covered the reactor and the material inside it. The exclusion zone around the plant was drawn at a 30-kilometer radius. Inside it, the town of Pripyat remained as the evacuation had left it. Furniture, documents, a gymnasium with equipment still arranged, a Ferris wheel that had been installed for the May Day celebration, scheduled for 4 days after the explosion. It was never operated. It had been installed days before. The wheel did not move.